We can begin to answer this question by first determining the angle that the plane is making with both observers, that last angle in the triangle that we don't know. We know, however, it has to be 180 degrees minus the other two angles, which tells us that that angle must be 113 degrees. From here, we can use this information and the law of sines to set up a proportion, and that will allow us to solve for one of the sides of this triangle. We'll solve for side B in this case. So the sine of 113 degrees over its opposite side, 2.3, will equal the sine of 42 degrees over its opposite side, B. From here we can cross multiply, and we'll end up with B times the sine of 113 degrees being equal to 2.3 times the sine of 42 degrees. From here we can divide both sides of the equation by the sine of 113 degrees, and what we'll be left with is B equaling 2.3 times the sine of 42 degrees divided by the sine of 113 degrees, or approximately 1.7. So once we know the value of that side of the triangle, we can add it to the second diagram, which is a mirror image of our first, but we're going to use it to draw in another triangle because what we're trying to actually determine is the altitude of the plane. So if we draw a height line or an altitude line, we can come up with a right triangle that now includes that side that we just determined. And again, we can set up a proportion using the law of sines, which will allow us now to solve for that side of the triangle that represents the height. So the sine of 90 degrees over its opposite side, 1.7, will equal the sine of 25 degrees over its opposite side, the height. Again, we're going to cross multiply, and that will give us h times the sine of 90 degrees is equal to 1.7 times the sine of 25 degrees. Now the sine of 90 is equal to 1, so h will equal 1.7 times the sine of 25 degrees, which will give us our final answer that the altitude of the plane is 0.71 miles.